Okay, today we are working 10-6. 10-6 is find the distance between 2 points on a coordinate plane and find the midpoint between the 2 points on a coordinate plane. Okay, coordinate plane is just a grid, pattern grid. We just need to know the x's and the y's, and we're going to find the length of it. So we're still using the a squared plus b squared equals c squared equation. It's just manipulated a little bit. So if we look at that key concept there, we have d, which is going to be the distance, is equal to the change in x plus change in y and then we're going to square root the whole thing. So looking at that, all they did is they said, hey, I had the c here, which they now substitute for d, the x point, the y point, and we do the difference. So it doesn't really matter if we go x2 minus x1, y2 minus y1. We could do x1 minus x2. We have to make sure that we subtract the points, and then we do square them. So that way, it doesn't matter if we flip these around or not, since we're squaring them. We just want to stay consistent, though, because there's other equations that require us to say we have this point that ties up to this point. You know, whenever we're thinking like slope, we want to make sure that that stuff ties together. So it is good habit of just saying I have the square root of x squared minus x, or x2 minus x1 quantity squared plus y2 minus y1, that quantity squared, and then we take the square root of that. We add those two together. So if we look at example number 1, they give us these points. So what we're going to do is we're going to plug those in. So d equals square root of 5 minus 1 squared plus 3 minus 2 squared. Okay, now you notice that I could say this is my 0.1, this is 0.2. And so I did flip it around, which we can see that it works. It doesn't matter if I said this was 0.2 and this was 0.1, it will work either way. So as long as I stay consistent with those, I do want to match them up. So I have 4 here, I have 1 there, 4 squared is 16, 1 squared is going to be 1. So I have d equals square root of 17. Square root of 17, 4 squared, gotta make sure I follow through. So I have 4 squared there is going to be 16. Oh, it helps if I copy the points right. So they have negative there. So this is going to be a positive. So I have square root of 16 and 5. So 25 and 16 is going to be 41. Okay. The square root of 41 is 6.4. So there it is. Double check, make sure we copy the problem down right. If you copy it down right, then we usually can work it out. All right, example number 2. Looking at this one, the Vaccaro family is having a home theater system installed. The TV and the seating will be placed in opposite corners of the room. The manufacturer of the TV recommends that the size of the TV that they want, the seating should be placed at least 13 feet away. If the grid squares are 1 foot long, the Vaccaro family's room large enough? So what we do is we look at the grid right there, and we find the points 11 or 111 and 7, 2. Okay, and that's what we're going to use for our equation. We're going to be plugging in, doing the same thing. So we have this, and we have 1 minus 7 quantity squared plus 11 minus 2 quantity squared. Okay, double check, make sure we did it all right. So D equals, we end up with -6 here. -6 squared is going to be 36. Plus, this one here is going to be 9, so 81. Doing the square root there. Which is going to be we need to do d equals the square root of 7, 1, 1. 117. Square root of 117 is 10.8. So the size TV they want is actually not recommended for this size of room. So they either need to go a smaller room or put it in a different room or build a bigger house. All right, example number 3. What we're doing here is we're finding the missing value. So they've given us the distance, they've given us 1 point, and one of the coordinates for the other point. So they give us the distance of 5. So 5 is going to be here. We have 0.47 and A3 are our points. So A is the one that we're looking for. So we're going to plug it in the same way, right? We can kind of battle some of our stuff by make sure that we go positive there. So A minus 4 squared plus 3 minus 7 squared. Like I said, once again, we want to make sure that we line up our points. So then what we have to do is go through and do the math here. Okay, so we have 5 equals square root of A minus 4 squared plus, this is going to be 4, so squared 16. Right? Make sure we keep our parentheses here. What we're going to do is we can then we then square both sides. So 25 equals A minus 4, that quantity squared, plus 16. Subtract over the 16. So we end up with 9. A minus 4 squared. Right here, I'm looking at that, and I would probably use that law of the perfect squares. And just do the plus or minus square root. So if I go plus or minus square root, I'm going to add the 3 over there. So I'm going to have 7 equals A, or negative 1 equals A. We have to kind of know what we're talking about here, figure out where the point is. No, positive 1. Right. Negative 3 plus 4 is going to be positive 1, not negative 1. So we have, those are our two answers. Since they're both positive, they will both work. The reason why they both work is just reflecting the triangle. Okay, as we think about the triangle, we have our point 7, and we know the distance is 5, so I'm going to kind of go here, but it also could be that way. Both of them gives us the right triangle. So it could go this way or that way, and so that's why it's giving us the 2 points, 1 at 4, 1 at 7. Okay, or 1 at 1, 1, 3, and the other one would be 7, 3 would be our 2 points. So that's why it's giving us those 2 points, because we know that it can mirror across, and that distance is going to be the same. Right? So that's why we're getting 2 points on this one. All right, next thing we got to look at is the midpoint formula. The midpoint formula is going to be a little bit different. Okay, well, midpoint is kind of the average point is what we're looking at there. So we're going to erase all this equations that we have, and we're going to rewrite for the midpoint. Okay, I said midpoint is, the average point. So M equals x1 plus x2 over 2, comma, y1 plus y2 divided by 2. And that's going to be our midpoint. Okay, you notice that we're adding them. Try to stay consistent with this. x1 plus x2, y1 plus y2. We just want to get in the habit of it so that way at future y's, whenever we get equations, we make sure that we stay consistent with that. We don't try to jump them around. That's easy little mistakes that we can make in the future. And just by getting in good habits now, it'll solve it. So the point that they want to find the midpoint is -1, -2, and 3, -4. Okay, so we're just going to plug it in. So we want the midpoint of those 2 points, and we want the point right in the middle is what we're looking for. That would be the midpoint. So -1 plus 3 divided by 2, comma, and then -2 minus 4 over 2. So the midpoint's going to be, this is going to be 2 over 2. So 1, comma, this is going to be -6 divided by 2, so -3. So there's our midpoint. So it's a point in between. So we graph these points real quick. -1, -2, 3, -4. Right there. We want the midpoint, so the point is 1, -3. Pretty close. Not too bad for a sketch. All right. Those are the problems. Make sure you really know those equations. They will come into effect whenever we're finding those, the distance between 2 points. Know the distance between 2 points is a straight line. That's the shortest distance there. And then we want the midpoint. So those are the main equations that we have. If you have any questions, let me know.